Water, a very essential substance for the survival of life. Let's look at its formation. Water is formed from hydrogen and oxygen. So when hydrogen combines with oxygen, it gives us water. So such an equation is known as a skeleton equation, which shows the reactants that participate in the chemical reaction to form the product. Now, let's count the number of atoms in this equation. So here on the reactant side, we have 2 atoms of hydrogen and 2 atoms of oxygen. And on the product side, we have 2 atoms of hydrogen and 1 atom of oxygen. So on the reactant side, we have 2 oxygen atoms, and on the product side, we have 1 oxygen atom. So does this mean that 1 oxygen atom is destroyed? Is that possible? No, it's not. Because we know that the law of conservation of matter states that matter can never be created nor destroyed. It can only change its form. So here we see the formation of water. Water is formed from oxygen and hydrogen. Now let's look at the molecular level. So what do you observe here? You see 2 molecules of hydrogen combined with 1 molecule of oxygen. Observe carefully. 2 molecules of hydrogen combined with 1 molecule of oxygen to form 2 molecules of water. So if you'll observe again, 2 molecules of hydrogen, 1 of oxygen give 2 molecules of water. So what did we get here? We saw that 2 molecules of hydrogen combined with 1 molecule of oxygen to give 2 molecules of water. So now if we look at this equation, we have 2 molecules of hydrogen combining with 1 molecule of oxygen to give 2 molecules of water. Let's count the number of atoms. So hydrogen atoms, we have 2 2s are 4, 4 hydrogen atoms. Oxygen atoms, we have 2. On the product side, we have 2 2s are 4 hydrogen atoms and 2 into 1, 2 oxygen atoms. So both hydrogen atoms and oxygen atoms on both the sides are equal. Such an equation is known as a balanced chemical equation. This is very important because according to the law of conservation of matter, matter can neither be created nor destroyed. It can only change its form. So the number of atoms on the reactant side should always be equal to the number of atoms on the product side. So in a balanced chemical equation, the quantity of reactants is always equal to the quantity of products. And that is why it's known as a balanced chemical equation. Let's look at one equation. Nitrogen combines with hydrogen to form ammonia. So if you look at the molecular level, we have 1 molecule of nitrogen. Each molecule contains 2 atoms of nitrogen. Similarly, 1 molecule of hydrogen contains 2 atoms of hydrogen. And 1 molecule of ammonia, it contains 1 atom of nitrogen and 3 atoms of hydrogen. Now if we observe the scales, we see that both hydrogen and nitrogen, they are not balanced. So how do we balance this? So on the reactant side, we see 2 nitrogen atoms. On the product side, we see just 1 nitrogen atom. So how can we make this 2, or how can we balance it? Is by increasing this number to 2. That is, we take 2 molecules of ammonia. When we take 2 molecules of ammonia, on the reactant side, we have 2 atoms of nitrogen. On the product side, we have 2 atoms of nitrogen. So you observe that the nitrogen scale is now balanced. But now look at the hydrogen scale. Hydrogen is not balanced. So now we have to balance hydrogen. On the reactant side, you observe 2 atoms of hydrogen. On the product side, you observe 1, 2, 3, 4, 5, 6. That is, 3 2s are 6 hydrogen atoms. So how do we balance hydrogen? We have to make this number 6 here, because there the number is more. So now we have to increase the number of hydrogen atoms on the reactant side. So we multiply this number by 3. That is, we take 3 molecules of hydrogen. So now we have 3 2s are 6 atoms of hydrogen on the reactant side and 6 atoms of hydrogen on the product side. So now both nitrogen and hydrogen is balanced. So this is a balanced chemical equation. Also, what do you observe here? You observed that we could change only these numbers. That is, the numbers before the substances taking part. This means we can change the number of molecules. The number of atoms which are present in any molecule is a constant number. This means one molecule of hydrogen always contains 2 atoms of hydrogen. We cannot increase or decrease this number. This is why we cannot change the subscripts. Similarly, one molecule of ammonia contains 1 nitrogen atom and 3 hydrogen atoms. This means this number is constant. We cannot change the number of nitrogen and hydrogen atoms in ammonia. So we cannot change the subscript. What we can do to balance is, we can increase or decrease the number of molecules. So while balancing, we have to keep in mind that we can only change the coefficients which are present before the reactants and the products. We cannot change the subscripts. Now let's try to balance an equation. We have an equation. Iron reacts with water to form Fe2O3 plus hydrogen gas. Okay, so let's look at the different atoms present. We have iron, we have hydrogen, and we have oxygen. So these are the 3 different elements present in the reaction. Now, let's try to count the number of atoms present on both the reactant side and the product side. So if you look at the reactant side, we have 1 into 1, 1 atom of iron. On the product side, we have 2 into 1, 2 atoms of iron. On the reactant side, we have 2 into 1, 2 atoms of hydrogen. On the product side, we have 2 into 1, 2 atoms of hydrogen. And oxygen, on the reactant side, we have 1 into 1, so 1. And on the product side, we have 3 into 1, so 3. Alright, so these are the number of reactants and products of different elements. So let's take our equation. Now, we see that there is 1 iron atom on the reactant side and 2 iron atoms on the product side. So how can we balance iron? We can balance iron by multiplying this number by 2. So when we multiply this iron by 2, that is, we take 2 molecules of iron, we now have 2 atoms of iron on the reactant side. We have not changed the number of hydrogen and oxygen, so they remain the same. Similarly, on the product side, we have not changed anything, so the number of atoms remain the same. Now our iron is balanced. Let's look at hydrogen. If we see, on the reactant side, we have 2 atoms, and on the product side, we have 2 atoms. This means that our hydrogen atoms are also balanced. Now let's look at oxygen. Oxygen, on the reactant side, we have 1 atom. On the product side, we have 3 atoms. So how can we balance oxygen? So we can balance oxygen by multiplying this number by 3. This is because here we have 3 oxygen atoms, here we have 1 oxygen atom. So to get 3 oxygen atoms on the reactant side, we take 3 molecules of water. So what do we get now? We get 2 atoms of iron. Hydrogen, we have 6 atoms now. And oxygen, we have 3 atoms. And on the product side, we have 2 atoms of iron. We have 2 atoms of hydrogen. And we have 3 atoms of oxygen. Now let's look at the situation. So our iron is balanced, our oxygen is balanced. But by changing the number here, we have changed the number of hydrogen atoms. So how can we balance hydrogen now? Here on the reactant side, we observe 6 hydrogen atoms. Whereas on the product side, we have 2 hydrogen atoms. So what can we do? We can multiply this number by 3. So now when we multiply this by 3, what do we get? On the reactant side, we have 2 atoms of iron, 6 atoms of hydrogen, and 3 atoms of oxygen. On our product side, we have 2 atoms of iron, 3 twos are 6 atoms of hydrogen and 3 atoms of oxygen. So now, if we look at our equation, we have 2 atoms of iron, 6 atoms of hydrogen on both sides, and 3 atoms of oxygen on both sides. This means that this equation is now balanced. So this is our balanced chemical equation. So by using these coefficients, we have balanced our equation. Now let's look at another equation. We have sodium hydroxide reacts with sulfuric acid to form Na2SO4 sodium sulfate plus water. Now let's try to balance this equation. What are the different atoms that are present? We have sodium, then we have oxygen, we have hydrogen, we have sulfur, and again oxygen, which is already covered. So these are the 4 elements that are present in the reaction. So now let's look at the atoms on the reactant side and on the product side. So let's count on the reactant side. We have 1 atom of sodium, we have 1 atom of oxygen here and 4 atoms here. So overall we have 5 atoms of oxygen. Hydrogen we have 1 plus 2, which is 3, and sulfur we have 1. Similarly, on our product side, we have 2 atoms of sodium. Then we have oxygen. We have 4 plus 1, 5 atoms of oxygen. Then we have hydrogen. So we have 2 into 1, 2 atoms of hydrogen. And then we have sulfur. There is only 1 atom. So these are the different number of atoms present on both the reactant and the product side. So now let's take our equation. Let's balance step by step. So on the reactant side, we see 1 atom of sodium, and on the product side, we see 2 atoms. So how can we balance this? We can balance this by simply using 2 molecules of sodium hydroxide. So when we multiply this number by 2, now we have 2 atoms of sodium. We have 2 into 1, 2, plus 4, 6 atoms of oxygen. We have 2 into 1, plus 2, 4 atoms of hydrogen. And we have 1 atom of sulfur. We have not made any change on the product side, so the number of atoms remains the same, which is 2, 5, 2, 1. Now our sodium is already balanced. Let's try to balance oxygen atoms. On the reactant side, we have 6 atoms of oxygen. On the product side, we have 5. So how can we balance this? So if you'll observe, we have 4 plus 1, 5 atoms of oxygen. So in order to balance this, we can take 2 molecules of water. When we do this, we have 4 plus 2, 6 atoms of oxygen. So when we do this, let's count the number of atoms again. So here, in this case, we do not make any change on the reactant side. So this remains the same. On the product side, we have 2 atoms of sodium. We have 4 plus 2, 6 atoms of oxygen. Now we have 2 twos are 4 atoms of hydrogen. And we have 1 atom of sulfur. So what do you observe? When we make it 2, that is, we take 2 molecules of water, we have balanced both oxygen and hydrogen. So now our sodium atoms are balanced, our oxygen atoms are balanced, our hydrogen atoms are balanced, and sulfur is balanced. This means that this equation is now a balanced equation. So when we use these coefficients, we have balanced our given chemical equation. Okay. Let's look at a question here. We have a given equation. Magnesium nitride reacts with water to form magnesium hydroxide and ammonia gas. So which of the following equations do you think is the balanced chemical equation? Let's try to balance this equation. Let's look at the different atoms present. We have magnesium, we have nitrogen, hydrogen and oxygen. Now let's count the number of atoms which are present. So on the reactant side, we have 3 into 1, 3 atoms of magnesium, 2 atoms of nitrogen, 2 atoms of hydrogen and 1 atom of oxygen. On the product side, we have 1 atom of magnesium, we have 1 atom of nitrogen, we have 2 into 1, 2 plus 3, 5 atoms of hydrogen, and we have 2 into 1, 2 atoms of oxygen. So these are the number of reactants and products which are present in the chemical equation. Okay, so let's look at our chemical equation now. So let's now try to balance our magnesium atoms. On the reactant side, we have 3 atoms. On the product side, we have 1 atom. So how can we balance magnesium atoms? We can balance it by simply putting a 3 here. That is, we take 3 molecules of magnesium hydroxide. When we do this, we get 3 atoms of magnesium, we get 1 atom of nitrogen, then we have hydrogen, we get 2 into 1, 2 into 3. That is 2 into 1 is 2 and 2 into 3 is 6. And this 6 plus 3, so we get 9 atoms of hydrogen and we get 2 into 1 into 3, which is 6 atoms of oxygen. Now let's look at our reactant side. Since we did not make any change here, so the number of atoms remains the same. Alright, so now our magnesium is balanced. Let's look at the other element, which is nitrogen. On the reactant side, we have 2 atoms. On the product side, we have 1 atom. How can we balance nitrogen now? We can balance nitrogen by multiplying ammonia by 2. So when we multiply this by 2, that is, we take 2 molecules of ammonia. Now we have 3 atoms of magnesium. We have 2 atoms of nitrogen. We have 2 into 1 into 3, 6 plus 6 atoms of hydrogen, which makes it 12. And we have 2 into 3, that is 6 atoms of oxygen. We did not make any change on the reactant side, so this number remains the same. Now let's look at our equation. We have 3 atoms of magnesium on both the sides and we have 2 atoms of nitrogen on both the sides. But now our hydrogen atoms are not balanced. On the reactant side, we have 2 atoms of hydrogen. On the product side, we have 12 atoms of hydrogen. How can we balance hydrogen now? Well, we can balance hydrogen by multiplying this. We have to make this 12. So now if we look at our equation, in order to get 12 on this side, we can multiply this by 6. When we multiply this by 6, we get 6 molecules of H2O. So overall we get 12 atoms of hydrogen. So now we have 12 atoms of hydrogen. We have 6 atoms of oxygen. And these remain the same. So we have 3 atoms of magnesium and 2 atoms of nitrogen. Let's look at the product side now. We have not made any change on the product side, so this number remains the same. So we get 3, 2, 12 and 6. So if we now look at a chemical equation, we have 3 atoms on both the sides for magnesium, 2 nitrogen atoms on both sides, 12 hydrogen atoms on both sides, and 6 oxygen atoms on both sides. So this equation, by using these coefficients, is now a balanced chemical equation. So what did you think we did here? We tried different numbers and we tried to balance the equation. So such a method in which we use different numbers and try to balance the equation is known as the hit and trial method of balancing the equation.